It's a big universe out there, and NASA's newest telescope is giving us a look at the very beginnings of that universe.
The James Webb Space Telescope had been scanning the inner solar system for weeks when it focused on Mercury, a planet often overshadowed by the more glamorous worlds of Mars, Jupiter, and Saturn. Mercury's close proximity to the Sun makes it difficult to observe in detail from Earth, and most missions have relied on flybys and brief orbital surveys to piece together a limited picture. Webb, however, brought a completely new capability into play. With its infrared imaging power and advanced spectroscopic tools, it could penetrate Mercury's harsh glare and reveal surface and atmospheric details that had never been captured before. The initial frames transmitted back to Earth were not what anyone had expected, and within hours of the data's arrival, a quiet but unmistakable tension began to rise among the scientists involved. Before we start, smash the like and subscribe buttons for more updates. The observations began innocuously enough. Mercury's sunlit side glowed with the thermal signatures one would expect from a planet so close to our star. The cracked, ancient surface was scattered with impact craters, scarps, and basins, all of which had been cataloged before by earlier probes like Messenger. But as Webb's detectors mapped the planet's infrared profile in finer resolution than any mission in history, patterns began to emerge beneath the surface layer, patterns that didn't fit the story of a world shaped solely by natural geological processes and solar bombardment. Areas in certain equatorial regions reflected unusual spectral readings, indicating compositions of metals and silicates that didn't match the surrounding crust or even the known geological history of the planet. What drew immediate attention was the spatial arrangement of these anomalies. They weren't random scatterings of mineral deposits or natural formations. Instead, they formed linear and geometric shapes stretching for hundreds of kilometers, aligned with astonishing precision relative to the planet's poles and orbital path. This geometric regularity was so distinct that a few analysts privately compared it to architectural patterns, something intentional, engineered rather than accidental. When the imaging moved into deeper scans, structures buried beneath layers of regolith seemed to emerge, their heat signatures faint but consistent, like ancient installations sealed away from the harsh environment above. The team pushed the telescope's limits to capture as much detail as possible, working quickly before the planet's position shifted relative to Webb's line of sight. As the data packets came through, a fuller picture began to form. There appeared to be vast subsurface cavities, enclosed chambers linked by what looked like tunnels, spanning regions far larger than any lava tube or tectonic fracture ever recorded on Mercury. Some of these voids were associated with concentrated pockets of rare metals, in ratios far higher than those found in naturally occurring ore deposits. The question became unavoidable. If these were the remains of something artificial, who or what had put them there, and when? Within hours of the first internal analysis, communications between various NASA divisions became noticeably guarded. Channels that were once open to broader scientific collaboration suddenly required clearance levels higher than many mission scientists possessed. The team members who had direct access to the raw data were instructed to cease any discussion of the findings outside specific closed sessions. Some scientists resisted, citing the importance of peer review and open analysis, but the directive was clear. The information was now classified. This decision sent ripples through the research community. For months, the James Webb Telescope had been hailed as the pinnacle of transparency in astronomical discovery. Its public image feeds had streamed breathtaking images of distant galaxies, nebulae, and exoplanets. The sudden clampdown on Mercury's data marked a stark departure from that openness. What had been an inspiring, collaborative mission now carried the heavy shadow of secrecy. Technically, there were explanations that could justify a shutdown of the observation sequence. The Webb telescope operates under delicate thermal and positional constraints, and when directed toward a target close to the Sun, its instruments are exposed to increased thermal load. Official statements could easily cite instrument protection or mission safety as reasons for ceasing Mercury observations. But within the walls of the project's control and analysis teams, many suspected this was a pretext to halt the flow of information before more data confirmed the implications of what had already been seen. The patterns themselves remained burned into the minds of those who had examined them closely. Some of the structures resembled vast hexagonal arrays, not unlike the way Webb's own mirrors were arranged. Others looked like stepped platforms with clear edges that defied the eroded randomness of natural terrain. One formation, located in the Caloris Basin region, appeared to be aligned with both Mercury's rotational axis and specific orbital positions relative to the Sun, an alignment so precise it suggested deliberate astronomical intent. This possibility was the most unsettling aspect for many in the team. If these alignments were intentional, they implied not just an advanced understanding of orbital mechanics, but a reason to embed such structures on a planet that endures some of the most extreme temperature fluctuations in the solar system. Mercury is a world where daytime temperatures can soar above 430 degrees Celsius and plunge to minus 180 degrees Celsius at night. Any form of long-term activity there, whether ancient or more recent, would require technology far beyond anything humanity has demonstrated. The data Webb collected also hinted at faint energy emissions from certain subsurface points. They were weak, almost lost in the background noise, but repeated scans confirmed their presence. These emissions didn't match natural geothermal processes or residual magnetic field effects. Instead, their frequency and stability suggested ongoing activity, albeit at a very low level. That was the moment some researchers began to speculate quietly and carefully about the possibility that whatever was under Mercury's crust might not be entirely inert. The political and institutional stakes of such a revelation would be enormous. If a definitive case could be made for artificial structures on Mercury, it would be the first unambiguous evidence of non-human engineering in the solar system. The implications for science, philosophy, religion, and geopolitics would be staggering. Every assumption about humanity's place in the cosmos would be called into question, and the public reaction could range from awe to panic. Controlling the narrative, then, would become a matter of high priority for any agency in possession of the data. Behind the scenes, debates flared among those who had seen the clearest images. Some argued that the anomalies could still be explained by natural processes not yet fully understood, perhaps the result of ancient impacts or unique volcanic activity combined with Mercury's unusual density and composition. Others countered that the sheer regularity, the precise alignments, and the presence of high-purity metals in localized deposits defied such explanations. It was during these discussions that the order came through to suspend Webb's Mercury observation program entirely. From a technical standpoint, suspending a target observation isn't unusual. The telescope has a long queue of deep space targets competing for time, and priority shifts often. But in this case, the speed and finality of the decision felt different. Within a day of the shutdown, archived public data on Mercury's Webb scans was scrubbed from easily accessible databases, leaving only sanitized summaries with no mention of the anomalies. Team members received explicit instructions not to discuss the specifics outside approved channels, and some found their future assignments suddenly altered or delayed. For the scientists who had dedicated their careers to open discovery, the moment was deeply disheartening. Webb had the capacity to transform humanity's understanding of not only the distant universe, but also our own celestial neighborhood. The thought that this ability could be selectively curtailed in the face of controversial findings was sobering. Even so, the implications of the Mercury images were too profound to dismiss as mere curiosity. If there were indeed remnants of a sophisticated presence on Mercury, it could mean that the solar system had been visited or inhabited long before human history began. The more one considered the environment of Mercury, the stranger this possibility became. The planet's lack of atmosphere, its violent solar exposure, and its barren appearance make it an unlikely candidate for any form of sustained activity. And yet, paradoxically, these same conditions might preserve certain types of structures or materials far longer than on more geologically active worlds like Earth or Mars. With almost no erosion from wind or water, anything built there could potentially endure for millions, even billions of years, silent and unchanging until the right technology came along to detect it. Webb's technology had provided that detection, even if only for a fleeting moment before the curtain was drawn. The telescope's infrared sensitivity allowed it to see past surface glare and pick out subsurface features invisible to optical instruments. It could distinguish between rock types, detect temperature variations mere fractions of a degree apart, and map spectral signatures that told a story in chemical and mineralogical detail. In the case of Mercury, that story appeared to contain a chapter that someone somewhere decided the world was not ready to read. The shutdown also raised questions about the broader purpose of Webb's inner solar system observations. While its primary mission is focused on deep space, the earliest galaxies, the atmospheres of distant exoplanets, the telescope is also capable of extraordinary planetary science within our own system. Each time it is turned toward a nearby world, it has the potential to uncover details that no previous mission could achieve. If Mercury's revelations triggered such a decisive reaction, what might similar observations of Venus, Mars, or the moons of Jupiter and Saturn uncover? In the absence of public access to the Mercury data, speculation filled the void. Independent researchers began combing through older datasets from Messenger and Mariner 10, searching for any overlooked hints of the anomalies Webb had reportedly detected. Some found subtle indicators, a strange symmetry in certain crater chains, unusually reflective patches on the surface, but nothing that matched the clarity of Webb's scans. Without the infrared precision and resolution that Webb offered, these clues remained ambiguous, easily dismissed as artifacts of image processing or geological coincidence. The secrecy surrounding the event, however, had an unintended effect. By cutting off the flow of information, NASA fueled curiosity rather than suppressing it. Within weeks, online communities dedicated to planetary science were buzzing with theories, some grounded in legitimate scientific inquiry, others spiraling into more speculative territory. The idea that Mercury might harbor the remnants of an ancient engineered presence, buried for eons beneath its scorched crust, captured the imagination of people far beyond the professional astronomical community. For those within the project, the memory of that brief window, when Webb's gaze peeled back Mercury's surface and something unexpected looked back, remained vivid. The images had been raw, sometimes grainy, but unmistakably strange in their geometry and composition. The data was incomplete, the picture still forming, and yet even in that incomplete form, it was enough to prompt the most dramatic intervention possible, shutting down the world's most advanced telescope from observing the closest planet to the Sun. Mercury itself, indifferent and silent, continued its tight orbit, locked in a gravitational embrace with the Sun that had lasted for billions of years. Whatever lay beneath its surface, whether the work of nature or the relics of something far older and more deliberate, remained hidden from the public eye. Webb's brief encounter with it had ended, not because the telescope could not look, but because someone decided it should not. And in that decision, a question took root, one that would linger long after the last encrypted packet of Mercury's data had been sealed away. When the James Webb Space Telescope was first proposed, its champions spoke of peering into the cosmic dawn, of reading the faint light of the first galaxies born after the Big Bang. Few considered that its unmatched sensitivity might one day be turned toward one of the most inaccessible planets in our own celestial neighborhood and uncover something that would rival any deep space discovery. Yet the moment Webb's mirrors, cooled to a whisper above absolute zero, were trained on Mercury, the dynamic changed. The decision to study Mercury with Webb in such detail was, on the surface, a matter of scientific completeness. Understanding the innermost planet could reveal much about the early solar system's formation, about the processes that shaped rocky worlds, and about why Mercury's composition was so anomalously rich in heavy metals. The telescope's infrared vision could bypass the dazzling interference of the Sun and see heat signatures invisible to optical telescopes. When it began returning its data, it quickly became clear that this capability had opened a door no one expected. Mercury is not an easy target. From the vantage point of a telescope like Webb, stationed at the L2 Lagrange point over 1 million miles from Earth, turning toward a body so close to the Sun requires meticulous control. The heat from our star could overwhelm the instruments if the angle of observation is off by even a fraction of a degree. Observations are often limited to brief windows, carefully planned to avoid direct sunlight spilling into the detectors. This made every second of Mercury's scanning precious, and perhaps heightened the urgency when those anomalous readings first appeared. The science team knew there would be no long leisurely period to confirm what they were seeing before the planet's position changed. When the deeper scans began revealing shapes under the crust, the mission entered territory with no precedent. To those familiar with the chaotic violence of planetary history, asteroid impacts, volcanic upheavals, crustal shifts, the neatness and order of these patterns stood out like a beacon. On a world as battered as Mercury, nothing stays perfect for long. The fact that these formations had endured still holding straight lines and precise angles suggested they had been designed with resilience in mind. The more sophisticated Webb's filters became in isolating these features from the surrounding geology, the stranger they looked. One formation resembled a long rectangular trench, evenly deep, its length extending beyond the reach of a single high-resolution frame. Another appeared to be a cluster of hexagonal pits, arranged with near-perfect symmetry. Both were buried beneath layers of regolith, likely the result of countless micrometeorite impacts and space weathering. Yet their underlying structure remained sharply defined in thermal mapping. By adjusting the telescope's spectroscopic settings, the team was able to analyze the chemical signatures of these areas. The results startled even the most cautious researchers. The metallic readings did not match the distribution expected from Mercury's iron-rich core spilling to the surface. Instead, certain metals appeared in purities approaching industrial refinement, levels not seen in nature without specific and energy-intensive processes. This detail alone was enough to raise eyebrows in quiet conference calls. Nature, even under extreme conditions, rarely produces concentrated alloys in geometric layouts. The thermal emissions, faint though they were, hinted at something even stranger. They pulsed, not with the regularity of a machine, but in a way that suggested some ongoing process beneath the crust. The intervals were irregular, the energy levels low, yet they persisted through multiple observation passes. Webb's instruments are designed to detect even the faintest of infrared sources billions of light years away. Here they were registering activity beneath the baked shell of Mercury itself. For some in the control center, the thought that these emissions could be a natural phenomenon was still plausible. Mercury is not geologically dead. It contracts as it cools, creating thrust faults that sometimes release heat. Yet the locations of the emissions didn't match known fault lines or volcanic features. Instead, they aligned with the subsurface geometries, as if linked in a network. That was when whispers of infrastructure began circulating in hushed tones among the few with direct access to the raw data. The implications of that word were staggering. If there was infrastructure, it had to have been built for a purpose, and that purpose would have been designed with full knowledge of Mercury's extremes. Such conditions would be hostile to any life as we know it, but perfect for protecting something from the ravages of time. Perhaps the planet's proximity to the sun, its lack of atmosphere, and its geologic stability had made it an ideal vault, a place to store, conceal, or preserve something far beyond the reach of weather, erosion, or tectonic upheaval. No one dared speculate openly what something could mean. Theories formed privately, and the more adventurous among them reached beyond the boundaries of conventional planetary science. Could this have been the work of an ancient civilization, perhaps not from Earth? Was Mercury, in its stillness, the solar system's oldest time capsule? If so, was it abandoned intentionally, or had its creators left under circumstances beyond their control? These questions carried weight not just in science, but in diplomacy, national security, and the deepest currents of human culture. The shutdown order that followed was both abrupt and total. No gradual scaling back of the observations, no public announcement of technical issues before the feed went dark. Just a swift end to all Mercury-targeted activity. Internally, the justification was couched in terms of instrument safety and the need to prioritize deep space science. But for those who had been present in the days leading up to it, the timing was too sharp to ignore. The most compelling images and data sets had been captured, analyzed just enough to recognize their significance, and then locked behind access protocols so restrictive that even some senior mission scientists found themselves cut off. The removal of public data was just as swift. Normally, Webb's planetary observations are made available in a relatively raw form within weeks, if not days. In this case, images that had been briefly visible in open databases vanished without explanation. Only processed, low-detail images remained, stripped of the thermal and spectroscopic layers that would reveal the anomalies. For the general public, there was no hint of what had transpired. For those inside, the message was unmistakable. This was not to be shared. The nature of Mercury itself added to the intrigue. The planet is tidally locked in a way that results in its day being twice as long as its year. This slow rotation creates conditions where parts of its surface bake for months in unbroken sunlight, while others endure extended freezes. Any subsurface system on Mercury would need to withstand the constant expansion and contraction of the crust, the relentless bombardment of micrometeoroids, and the absence of any atmospheric shielding. That anything could endure such punishment over geologic timescales speaks to either extraordinary engineering or to natural processes far outside our current models. One of the most tantalizing possibilities discussed privately was that Mercury's core, being proportionally larger than that of any other terrestrial planet, might serve as a natural power source for whatever lay beneath the surface. If the structures were real, perhaps they were drawing upon the planet's internal heat or magnetic field to maintain minimal operations. This could explain the faint, persistent thermal pulses, residual activity in a system built to operate for millennia, even in near hibernation. As Webb shifted its gaze to other targets, the memory of Mercury's brief moment in its field of view began to take on an almost mythic quality among those who had seen the data. They spoke of it obliquely, careful to avoid specifics, but their tone carried the weight of something extraordinary. Some likened it to glimpsing the shadow of a vast object through a break in the clouds, there for an instant gone before one could truly comprehend it. Outside the official channels, a few independent astronomers attempted to reconstruct the possible findings using older mission archives and ground-based observations. While none could replicate Webb's resolution, some claimed to detect faint hints of the same alignments in historical images, though these were easily dismissed as artifacts of light and shadow. Without Webb's infrared precision, there was simply no way to confirm the existence of buried structures. This gap in verifiable evidence ensured that, for now, the anomaly remained in the realm of controlled knowledge. The sudden secrecy also hinted at broader implications for the use of Webb in solar system exploration. If one discovery could provoke such a clampdown, it raised questions about what else might be found and hidden in our own planetary neighborhood. Venus, shrouded in its acidic clouds, could conceal far more than we know. The icy moons of Jupiter and Saturn with their subsurface oceans are already prime candidates in the search for life. If Mercury's anomalies were deemed too disruptive to reveal, would future Webb observations of these worlds face similar censorship? From a purely scientific perspective, the loss of continued Mercury data was a blow. Follow-up observations could have determined the depth, composition, and precise geometry of the subsurface features, potentially distinguishing between natural and artificial origins. With those opportunities lost, the mystery was effectively frozen in time, preserved only in the encrypted archives of the agencies involved. Some of those close to the mission privately hoped that future political or institutional shifts might one day unlock the data. Others were less optimistic, believing that the stakes, whatever they were simply too high for disclosure in any foreseeable future. Until then, the public would continue to see Mercury as it always had been, a scorched, airless rock orbiting close to the sun, unremarkable beyond its extreme environment. And yet, for those who had looked deeper through Webb's eyes, that image would never again be complete. They knew that beneath the battered surface, hidden in darkness and time, there was something else, something that had prompted the sudden silence of one of humanity's most ambitious scientific instruments. The knowledge of that silence was its own kind of message, one not transmitted in radio waves or recorded in spectral lines, but felt in the abrupt absence of inquiry. In the months that followed, the space science community returned to its usual rhythms. Webb dazzled the world with images of distant star-forming regions, ancient galaxies, and the atmospheres of far-off exoplanets. Mercury faded once again into the background of public interest. But among a select few, the memory lingered like an afterimage, stubborn and insistent. Every time a new image of a distant galaxy was released, they remembered that the same instrument had once looked far closer and seen something that changed the rules of the game. The decision to end Mercury observations left a void not just in data, but in trust. It reminded those who watched closely that even in the era of unprecedented technology, the flow of knowledge can still be controlled, shaped, and withheld. For all its promise, Webb had become, in that moment, a reminder that discovery is not always the same as revelation. Sometimes the truth remains locked away, not for lack of tools, but because of the choices made by those who hold the keys. And somewhere, on the innermost planet of our solar system, the anomalies remain, buried, enduring, and untouched by the passage of time, waiting for the day when eyes will once again turn their way, and perhaps finally refuse to look away. In the weeks after Webb's sudden withdrawal from Mercury, the world's attention was easily steered toward more distant and aesthetically stunning images. Spiral galaxies glowing in deep blues and reds, massive star-forming nurseries lit by ultraviolet radiation, and atmospheric studies of exoplanets showing exotic chemical compositions. These were spectacular, safe discoveries, beautiful to the public, valuable to scientists, and entirely uncontroversial. But among the few who had been present in the secure rooms during Webb's Mercury scans, the contrast was glaring. They had seen data that refused to fit comfortably within the accepted story of planetary geology. The raw spectroscopic charts were unlike anything they had studied before. In one wavelength range, the readings revealed unexpected resonance patterns, sharp peaks where there should have been smooth gradients, as if the incoming signal had bounced off surfaces of uniform composition buried beneath the crust. In another, the data hinted at voids filled with material whose density was inconsistent with natural rock, but too compact to be loose regolith. What troubled the most disciplined analysts was that these anomalies did not appear as isolated curiosities. They were part of a coherent whole. The geometric alignments between regions hundreds of kilometers apart, the consistent material composition, and the faint thermal emissions all pointed toward interconnectedness. In science, random anomalies are often expected. Systems are noisy, and nature produces its share of improbable coincidences. But coherent patterns over such distances suggest design. When the team attempted to map these features against Mercury's known history, the problems deepened. The planet's surface records 4 billion years of impacts, volcanism, and tectonic compression. Any artificial formations dating back to the earliest eras would almost certainly have been obliterated or buried beyond recognition. That left two possibilities, both equally disquieting. Either the features were far younger than the planet's surface, suggesting construction on a geologically recent timescale, or they had been built with such durability that even billions of years of bombardment had failed to erase them. Geologically recent activity raised a new set of questions. Mercury has no weather and little tectonic activity compared to Earth, but it is not entirely inert. Volcanic plains cover much of its surface, some formed less than 1 billion years ago. If any construction occurred after this volcanic resurfacing, it would have been during a time when conditions on the planet were already harsh and unwelcoming. That meant either the builders were adapted to such conditions or they possessed technology capable of neutralizing them. Durability on billion-year scales, on the other hand, implied something beyond even our most ambitious engineering. The strongest terrestrial structures made of concrete, steel, or composites would eventually crumble under the unending micro-impacts and extreme temperature swings of Mercury. To survive unaltered over such spans would require materials and structural principles humanity has yet to fully understand. There was also the matter of placement. The anomalies were not randomly distributed across Mercury's surface. Several were located near regions where the planet's magnetic field, though weak, interacts with the solar wind in unusual ways. This hinted at a possible exploitation of electromagnetic phenomena, either as a source of energy or as a means of communication. The idea that such structures might be intentionally positioned to interact with the sun's activity, cycles of radiation, magnetic storms, or plasma flows, was speculative but difficult to ignore. Even more intriguing was a cluster of features near Mercury's polar regions. The poles, unlike the equator, contain permanently shadowed craters where ice has been detected. In a place otherwise scorched by solar heat, these icy pockets are stable, shielded from direct sunlight for eons. The anomalies near these craters suggested a potential interest in water, one of the rarest resources on the planet. If an advanced presence had once been active there, ice could have been invaluable for sustaining operations, whether for life support, industrial processes, or something more exotic. No matter how far the speculation went, the team kept circling back to the question of intent. The configurations of the anomalies suggested purpose. Straight lines and regular angles are the fingerprints of intelligence, and Mercury's conditions make their preservation improbable unless they were deliberately maintained. Was this a base, an outpost, or something akin to a library, storing data or artifacts? Or was it a station for observing the Sun, positioned at the closest possible stable orbit? The Sun itself became a focal point in these deliberations. Webb's sensitivity to thermal gradients allowed it to capture subtle interactions between Mercury's surface and solar radiation. Some of the subsurface geometries seem to be oriented towards specific points in Mercury's orbit, as if designed to align with solar events, eclipses, flares, or specific magnetic field orientations. This possibility transformed the anomalies from mere curiosities into potential instruments, vast hidden devices using Mercury's body as a foundation. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA hiding Mercury's secrets? What do you expect happens next? We want to hear from you. Thank you for watching, and see you next time.